Hi everybody and welcome back to a special makeup video session of Computer Science 1. Hi everybody! As you know, we've had a couple of snow days. Hopefully by now you've looked at the other snow day video that covered some other topics. Just because we're so far behind after 2 days, I would like to cover a few more topics in this special makeup edition of the video. Very exciting. But today there's a few things I'd like to cover just so that we're ready for what comes later in the semester. And hopefully you'll watch this video and the other one and come to class Tuesday and Thursday ready for some epic rounds of the code is right and to do some handout practice problems in class in preparation for the midterm. So the first thing I'd like to touch on is I'd like to revisit very briefly opening files. And if we get out of this and go back to our code and look at this, this is the program we did in the last video that reads from one file and outputs to another file while also outputting to the screen. And just to refresh your memory, we have an ifstream input file. The ifstream is the variable that is our connection to the file that we're reading from, and we've called this input file. We have an ofstream. The ofstream object is our connection to the output file, and we've named this output file. Now, these input and output files don't work unless we explicitly tell them what other file, the name of the file we want to use on disk. And so right now we've been using datafile.txt for the input file, and we've been using output.txt for the output file. Now, of course, every time we open one of these files, we create a connection between the file on disk and our program that we can read using input file or output file. And we have to check and make sure that happened correctly. So we have these checks to make sure the file opened, one for input file and one for output file. Once we get there, then we're able to just create a variable, in this case animal. We read something from the input file into animal. Then using cout, we output what we saw to the screen. And then we also output it using the same angle operators to our output file. Once we're done, we call these two close methods to make sure everything closes clearly, and somehow however to return zeros. Now it's correct. All right, so that's our program we had before. Let's just stop for a moment and make sure that it is compiling correctly. It does, and we run it. Uh-oh, something happened. File not found. So let's go back and take a look at this error message for file not found and see what we have. Well, here's what we had. We had datafile.txt, and it's saying file not found for datafile.txt. Well, it could have gone wrong. Let's take a look and see. So we do an ls, which shows us everything, and there's some other things in here, but aha, we no longer have a datafile.txt. Instead, we have two other files, lizards.txt and mammals.txt. Let's just take a quick look at each one of these. The lizards.txt consists of a snake, iguana, frog, and dragon. I guess that's right. And the mammals.txt consists of cat, dog, moose, rat, unicorn, lion, and bear. So here's our problem. Now we no longer have a single file that we're reading all our data from. We have two different files, and we'll have to choose which one we want to input. So what we're going to do now is change this program so that instead of working directly off of a hard-coded file name, in this case datafile.txt, that we're going to ask the user what file name they would like to open. Okay? So we're going to have to do a few things. We're going to have to output a prompt for the input file so we know what they want. And then read the file name in. And then we'll be able to input that. Okay, pretty straightforward. So we say cout, please input the name of the input file. And we will put this into a thing called input file name. Now we haven't declared that variable, so we'll have to go do that. Let's say it's a string, input file name. And now we've output the prompt and we've read the file name. It just stands to reason now that what we need to do is change this input file to open from that hard-coded string literal, that is the datafile.txt contained in those double quotes, and we just change it into input file name. Okay? So the program's the same, except instead of opening datafile.txt, we ask the user for the name of the file here in the cout. We read the input file name on the CN, and then the file we open, or the file that we connect to the input file, is called input file name, which is the name of the thing we read up there. And everything is golden, we're happy, we're cozy, we move along, and let's just run off and check and make sure that this compiles correctly. So I compile, it compiles cleanly, so we're happy. So let's take a second and run it. We say files. It asks us for the name of the input file, and we saw that there were two of those, lizards.txt, and that worked beautiful. And we can run it again and say mammals.txt, and that worked beautifully as well. And if you'd like me to prove that the output file stuff is still working, we can do more output file, output text, and it'll show us what was the output of the last run. So we're happy, right? Now we can, by prompting the user for the file name, get it to work just fine, and we're happy. Well, let's see. We're sort of happy. And the reason we're sort of happy is I am doing this on my Mac computer. And as a reminder, there is a difference in the compiler between the Mac, if you're doing this on a Mac or your PC at home, and the compiler on CS class. So, just to be cautious, and I would encourage you to do this, let's jump on over to CS class and make sure everything works there. Off camera, I copied the files.cc program over to CS class, so it should be waiting for us when we get there. And we can test and make sure it works correctly. Okay, I logged in. Here we are. Here's the files.cc program, which just worked for us on my Mac. And let's compile it now, and we'll make sure that it works over here as well. And look, something bad has happened. And here's what happened. The bad thing that happened here is that even though it compiled cleanly on my Mac, it did not compile cleanly on CS class. And that's a problem. Let's take a look and see what we said. It says, well, at line 20, there's an error, no matching function call to ifstream. If you recognize that right there, open. Something happened. So let's edit that and see what's going on here. So here we are opening input file name. This line of code, which I'll put in the center of the screen, worked very well on my Mac and is not working at all on CS class. Let me explain why. It turns out that different versions of the compiler, particularly the older ones like are on CS class, don't work with C++ strings. The open call right here only works with C style strings. So to get this to work, we have to do C_str open close parentheses. This converts the C++ style string into a C string, which should, and we'll check and make sure this is the case, oops, which should compile cleanly, and it does. You can see that that error has gone away now that we have added this C_.string. So here is why it's important to test your code not only on your computer but on the CS class computer. The compiler is different. It has different capabilities, and some of the stuff that you will get away with on your computer will cause you to lose a lot of points when your program does not compile correctly. All right, so the whole point of this was to show you that you can work with strings and use them to open file names. In fact, I'm just going to go ahead and convert this to a C string right here on my Mac, and then we'll exit out of CS class, and we'll make sure that it still compiles. Even with the C string, it does. It does. So even on my Mac, it will work with this C_string here, so you should make sure you do that. All right. The takeaway lesson here, two things. You can absolutely just read a file name as a string and open that. However, you should use this .cstring part for your code to work correctly on CS class. So that's what I wanted to show you about opening files, that you could absolutely get user input in the form of a string that contains a file name, that you could then use that to open the file. However, you have to be careful to use the C_str method. Otherwise, it may not work on CS class even if it works on your computers. I'd like to move on now and show you one small thing that we didn't get a chance to cover before. It's a conditional. Now you might remember a conditional is something that depends on a condition. The conditional we've seen so far is an if statement. So I'd like to show you a little piece of code here. And this should look pretty familiar to you. This is our algorithm that we use to check and see if a number was even or odd. So we declare an unsigned int integer. We say enter an integer above 0. We're only accepting positive integers right now, which is why we're doing unsigned. And we do cin into integer. We say if integer mod 2 is equal to 0, that means it was divided evenly by 2 and the number is even. Otherwise, it's odd. So let's just take a second and make sure that works. So we compile it. The conditional, it works. We run it, enter an integer above 0. Let's say 45. That was odd. If we run it again and say 100, that was even. It seems to be working. Okay? Now, we all know that programmers are lazy. And we want programmers to be lazy in a good way. We want programmers to be lazy in a way that makes less work for them. So, it turns out there's another way to write this if statement, and it's called the conditional operator, which is a question mark. It's possible to replace this entire conditional operator by a question mark. And here's how you do it. You say cout, angle, angle, and now we have the same Boolean check. Integer mod 2 equals 0. And this right here is where it gets interesting. We say question mark. Integer mod 2 equals 0 question mark. This is the if statement. And if it's true, we do the first thing, which is even. We have a colon. And if it's false, we do the other thing, which is odd. And we are done. And we have compressed this whole if statement, if integer mod 2 equal to 0, cout even odd, into one line. We cout, we check if mod 2 is equal to 0. If so, this whole thing becomes even. If not, this thing becomes odd. So this is a compact way of changing this if statement. Let's actually see if it works. I don't use this very often, so hopefully I typed that correctly. I did not. Oh, okay. I see I made a small error here. What I have to do is have parentheses around the entire statement so that it gets evaluated before it outputs anything. And now we'll try again. Compile it. It worked correctly. And now what we're going to see is when we run this, we're going to input an integer. This block right here is going to determine whether it's even odd and print out even or odd. And this single line over here is going to look at it and determine if it's even or odd or print out even or odd. So we should see the output twice. So conditional, if we do 45, we get odd, odd. If we do 100, we get even, even, which is what we want. So this is a compact way of representing an if statement using the question mark operator or conditional operator. Let me tell you something about the conditional operator. It is a tool of the devil. Now, I'm not saying that it's always a force for evil. However, it makes your code more compact, it makes it dense, and it can make it harder to read. If you're reading this piece of code, you say, oh, if integer equals 0, do this, otherwise do the other thing, and it follows down naturally. Here, you're couting, you are doing all the operations and output all in one line, and it is actually kind of hard to read. Again, remember a program is an algorithm that is designed for a computer to execute and for people to read. There are appropriate times to do this, and this is typical what one might look like. However, I encourage you not to use the conditional operator. I encourage you to space out your code and make it larger just because it's easier to read. However, I wanted to show you this, the conditional operator, in case you ever ran across it while you were reading other code. All right? So, conditional operator is a question mark. You can use it to replace an if statement. It's a tool of the devil. All right, so that was the conditional statement. It's a compact form of an if statement, one that I encourage you not to use because I personally don't believe it generally helps with code readability. Sometimes it does. You can make arguments when to use it. Most people use it in the single line output like I just showed you. It comes down to a matter of style and preference. Let's move on to something else. We have seen the conditional statement. I'd like to show you a different kind of statement for choosing what flow of control to do in the program. In order to do that, I'd like to develop a small program first. Here's a program that we want to write. We want to write a program that takes a character as input and outputs if it is a vowel. Well, that should be pretty easy, shouldn't it? So if we're going to input a character, let's go ahead and do this. Cn, we need a character, and we're going to call this input. If I can type, which I apparently can't. And we can input something into that. We say Cn into input. And we need a prompt, cout enter a character, and I will tell you if it is a vowel. All right, so we output a message, we input a character into input. Now we have to check and see if it's a vowel. So what do we know about vowels? A, E, I, O, U, and sometimes Y. So let's write a statement that checks this. So we say if input is equal to A, or input is equal to, but we have lowercase and uppercase, A, or, boy, this is going to get boring pretty quickly, input is equal to E, or input is equal to uppercase E. All right, this kind of sucks, so what I'm going to do is I'm going to finish typing all these out, and I'm just going to jump ahead in the video and skip all the typing part so you don't have to look at it. All right, I'm done now with this first statement, A, E, I, O, U. And in this case, we say cout. Yes, it is a vowel. Pretty exciting. All right, now we have to take care of the case it's not a vowel. In the case it's not a vowel, we have either Y or some other consonant. So we need to check and make sure it's not a Y. So we say else if, here we go again, input equals, quote, Y, quote, or input equals, quote, capital Y, quote. Then what we do is say cout sometimes a vowel. And then if we reach here, we know it's not one of the vowels that we know it's not Y, so we can go out and say else cout not a vowel. All right, so we have this program that's making all these checks. It's checking if it's an A, E, I, O, U. In that case, it's a vowel. Otherwise, if it's not one of those, we check and see if it's a Y. If it is, we say it's sometimes a vowel, otherwise the output, not a vowel. So let's go ahead and compile this and make sure it works correctly. All right, that seemed to work. Let's run it and see what happens. Enter a character, A. That's great. A is a vowel. E is a vowel. Capital E is a vowel. Y, X is not a vowel. Capital X is not a vowel. Y is sometimes a vowel. So our program seems to work well. That is, it's working correctly and giving us the answer we want. Let's go back and take another look at the code, however. This statement right here, this long if statement, is ugly. And it's a pain to type. I don't know if you noticed, but I had to pause the video for a little while I typed it out. just to keep you from dying of boredom in the minute or so it took me to do that. So we know programmers are lazy. Programmers are lazy in that they want to be efficient. And one of the ways that programmers are efficient is they write the language to make it easy sometimes to support complex things. So we can replace this entire code with something easier. Now, before we go about replacing, let's just talk about what exactly we're trying to do here. What we're trying to do is match exactly one of these choices, A, capital A, E, capital E, so on through O and U. We also are looking to match lowercase y and uppercase y, and we're also looking to match the case that it is none of the above. Well, since programmers are lazy, they have developed a special language construct to do exactly this, and it is called the switch statement. The idea of a switch statement is that you give it some Boolean condition. You give it some item, and it can be either int or character. And then you have inside here a number of cases. You say case whatever, and you can have either a number here or you can have a character here, depending on what you're using, and what you want to do underneath. Now you may ask yourself, how is this easier, Clay? Because look, I have this case A and I have to see out something as a vowel. I have to put this break underneath there, as we'll see in a second. Well, here is why. Because once we have this and we're able to switch on things, we can add other cases that we want to match to that particular item as well. So instead of just saying case lowercase a, we can also do case uppercase a. We can do case E, and so on. And so what I'm going to do is I'm just going to cut and paste the number of these things that I need. A, E, I, O, and U. And what happens is if any of these things match, A, E, I, O, or U, we reach this cout statement as a vowel. If we want to have some other cases, which we do because we're looking for also lowercase y or uppercase y, we can have cases for those. We can say cout is sometimes a vowel. And the very nice thing about this switch statement is we can have default. And the idea of default is if it doesn't match any of these other cases, it will match the default. So in this case, if it doesn't match any of the letters, if it doesn't match y, it's going to be a constant. We can say cout is not a vowel. I don't remember if I got the individual cases exactly right. We have is a vowel, is sometimes a vowel. We don't have it exactly the same, but we'll see. So this switch statement, and here we have to have an int or character. We're going to be switching on input, which is the name of the variable that we had up here for reading the character. And what we're going to see is now we are actually doing this matching two different ways at the same time. So let's see if this works. It compiled correctly. We'll run it. Yes, it's a vowel, is a vowel. So this yes, it's a vowel came from the if statement that we had before up here. Yes, it's a vowel. And the is a vowel came from the switch statement, which just said is a vowel. Now the switch statement is kind of cool. And the thing about the switch statement is it lets you select exactly one thing, either a character or an integer, and go to that case. Okay? And so we're able to use it in place of these kind of potentially complicated if statements. And it's much less verbose and it's easier to read. It makes us happy. There are a couple things to be aware of, though. And that is, this is an oddity in C++ and something that probably shouldn't be. What happens is when a particular case matches, so let's say input is lowercase a, what happens is it matches this case here, and then starts executing at this line of code. Now you can say to yourself, Clay, there is no line of code there, and you said, that's right. It goes to the next line, which is matching big A, that does nothing because it's little a, little e, so on down, and eventually reaches this is a val. After the is a val, it goes down to this next line, which is break. The idea of breaks means don't go down anymore. A common error is to forget the break. And if I take the break out and we run this program again, what we're going to see is that when we have a val, it prints out is a val, but also falls through, which means it goes on to the next line. It also says is sometimes a val, which is not correct. So I run it, I say it's a yes, I give it an A. We get the yes, it's a val from the if statement. We say is a val from the switch statement, but we also get is sometimes a val because we forgot the break statement. So almost always, 99.9% of the time, you're going to want a break statement after your code but before the next case, unless you have some compelling reason to specifically let it fall through. If you're going to let it fall through, what you should do is put a little comment on here that you are falling through on purpose if you don't have the break statement so that people will know. Okay, other people who read your node won't think it's a bug. All right, so that in a nutshell is the switch statement. It's very useful. We haven't had need for this in even our projects so far, and the reason we haven't had need yet is because we haven't really been working with characters. However, I can assure you for one of the projects coming up, you will want to use a switch statement because we're going to be reading choices from a menu, and this is an excellent thing to use to read choices from a menu. So we looked at a conditional, and the very last thing we looked at was a switch statement. Yeah, that's it for today. Hopefully we'll be in class later this week, and we'll start talking about some other things. The readings that match what I've talked about are posted on the class website. I think we're up through chapter 4, through some different sections in chapter 4. Since I kind of went over these things quickly, it would probably be to your benefit to go through the textbook, which is terse and short and just covers the good stuff, and look at the different things in there that we've covered in class to get a second view of them. All right, have a good afternoon, and I will see you in class shortly.